Hey, this is Don from Padlock Technologies again with another video. Today we're going to talk about back-to-back VPC. Now, I'm surprised that I got this question. Do I see back-to-back VPC in a lot of data center designs? It really depends. It depends on what they're doing. Most of the time I see this in storage when they're putting storage together with LAN or a unified fabric. I kind of see it there. But most of the time, when I deal with, it's going to be like a VXLAN, MPBGB, VXLAN kind of multi-site situation, whether it's going to be ACI or NDFC. I'm starting to get a little curious about Cloud Vision and Arista. So I may be doing that from a training standpoint, getting my feet wet into the Arista world. I know Cisco people are going to kill me about going to the enemy, but I'm a networking guy. So I want to know everything. Juniper, Arista, Cisco, whatever Aruba is going to be called, you know, that type of stuff. So we're going to do it at the whiteboard here just to give you a brief overview of back-to-back VPC. And then I'm going to show you what it looks like in the lab. And when I show you what it looks like in the lab, I did add some extra stuff in there, and I'll just go over it simple. All right. So back-to-back VPC. Let's see here. So do B2B VPC. Basically, what it is you're going to have two VPC domains back to back. So what you're going to do is you're going to have your first VPC up here. We're going to have that support channel there. Let's say this is the peer keep alive. And then we have our first VPC up here. So this will be VPC, say 100 is the domain. And then at the bottom, you're going to have another VPC. And this will be VPC domain 101, right? Now, in between here, you're going to have your port channels. So you'll have your port channels in between. 1, 2, 3, 4. And that's what you have. Now, normally in this setup, the L2 to L3 demarc is going to be at the top. So right here, it'll be L2 here, L3 here. Okay? So that really means your SVIs will live on this one here, and this one here. And then since these are going to be port channels, this is basically going to be active forwarding because you're going to use all the links here to, forward traffic up to the SVIs and stuff like that. Now, downstream, you can have more switches downstream, but now from a spanning trees perspective, the first one is going to be the root. So the first VPC is going to be the root for both. So as you know, when you do VPC, both pairs need to be the root for that domain. But in this situation, the top VPC is going to be the root. And then this one here, this VPC will be the secondary. Okay. So from a L2 forwarding standpoint, we're going to have all our root ports going up to the root that way. So port channels, so port channel. And then downstream, the root is still going to be here, but the secondary is basically everybody's going to go to the secondary to get to the root. So that's back-to-back VPC in a nutshell. Most people, most data centers, you probably won't see this, right? Most. You're either going to see a collapsed core design with one VPC and then everybody's going to be top of rack switches or something like that. Or God forbid, FEX modules. If you know about the Nexus 2Ks, give me a thumbs up or a comment or a like in the video because those were not the best thing in the world when they introduced those. I understand the concept, but fabric extenders really did not. It wasn't the best thing to do. And then, or you're going to see like a EVPN fabric. Most of the time is what you're going to see in data centers. But you may see this. So knowing what this is will help you if someone told you, hey, we have a back-to-back VPC in our data center. Okay. So now that that's out the way, let's look in the lab and then I'll show you exactly what that looks like. Now you're going to see a whole bunch of other stuff, and I'm going to go through everything in the lab. So let's check this out. So now, the good old EVE-NG lab. I promise you will not see the firewall lab that you saw in like 12 other videos. Let's log in here. And I believe I have that running already. Yep. So let's lock in here. So here is the infamous back-to-back VPC lab. So let me explain a little bit. So we have our network edge, right? And we have port channels going to some ISRs here. Now, if you're going to do this in your own EVE environment, you need to use either the CSR or the ISR. You could use the XR routers as well, because the port channel configuration won't. It's not port channel; it's bundle ID. So you just need to know that. So I'm running BGP or eBGP between the network edge, IBGP between my two network edge routers, but eBGP up to the ISP routers. Then we're running port channels down to each respective VPC peer, and then we're doing OSPF. I don't know why that keeps coming up. We're doing OSPF. Now there is a certain command that I did on on the bottom VPC or VPC 100, so that peering is allowed. Because if you do not do this command, what ends up happening, if it goes over the peer link, it will drop it, right? Because it decrements the TTL value, right? So what ends up happening is you have to use a special command called layer 3 peer router to allow the peering to happen on both VPC peers, right? Because if you don't do that, it'll form on one and it'll just be EX start on the other one. All right. So if we go into our routers here, just so you can see it. So we do show IP OSPF neighbor. As you can see, I have a DR and a BDR, which is going downstream, obviously from a routing perspective. We have our routes here. So I have a couple routes that's running. I'm also running HSRP on my L3, L2, L3 DMARC VPC, which is VPC 100. So we got a couple networks here. We have VLAN 8, 9, and 10. The VIP between all of those are going to be .254. And then I'm advertising them in OSPF. And then from a BGP perspective, we're going to pipe that section around the BGP. You see me redistributing OSPF 1, which is basically from the router down to the VPC. And then if we just do show BGP, IPv4, unicast, if you're going for any kind of CCNP or CCIE exam, you really need to get let's just say you need to be very fast in these type of commands. You should know these commands, right? By the way, so get comfortable with this. Do a lot of labbing to get comfortable with this. So this is what I'm advertising. Now I want to show you a bonus command here for my BGP people. I love BGP, by the way, because it's so extensible. You can do so much stuff with it. You need to know regex commands. So you need to know how to search AS or search routes using the AS number. Okay. So what you need to do is do a regex. All right. So for this, you do show BGP. I'm going to do the quad zeros that I'm getting. IPv4 unicast. And I believe it may be regex. Let's see if I can find it here. Because I may have to do it a different way and not use the BGP command. It may be show IPBGP. Yeah, I may have to do it this way. Why I didn't put it in here? So IPBGP. There it is, reg expression. So see, this is why I hate. So when I use the BGP, actually that was in there already. What am I doing? I was getting ready to say, see, this is what happened when you go in blind a little bit. So show BGP, IPv4, unicast, reg expression, and then you got to give it the reg expression. So what I'm going to do is a reg expression that says it needs to end, it should have started in ASN 65002. That's what I'm going to do. So what I want to do is I'm going to do _65002 $. Now, hopefully this works. And there you go. So basically, what that regex command does is it says, show me all my routes that started in 65002. So the dollar sign is basically the end of the expression, and then a caret could be the beginning of the expression, right? So this is off topic, but I wanted to show this just in case because somebody did ask me about this, the regular expressions. So if I wanted to do something where it was like, hey, show me a AS that show me the routes that went through 65002 and it didn't have to start there, I would do this. So this says, hey, show me a route that has 65002 in its AS path, right? If I did something like this, that's basically saying, hey, the caret is the beginning. So show me something with AS 65002 in it. All right. So that was a brief off topic how to search routes in BGP using regular expressions. If you want me to do a deeper dive into that video, hey, make a video on this with multiple ASs and put it in the comment, and then I'll work on the lab and put that in there. Now back to this. From a VPC peering standpoint, I will show you one of these. So let's go into our Nexus switch here. So the first thing we're going to do is we're going to go show VPC brief to give us a brief overview of our VPC. So our peer keep alive is up and our peer links are up. And we can see that there. I have a couple virtual port channels, which is 3, 4, and 5. That's going downstream, by the way. So we're good there. From a routing perspective, we have OSPF running. So we got our OSPF neighbors. Obviously, since I have stuff VLANs allowed over the peer link, they're going to be peering itself. So you're going to see a bunch of that. Now, from a route perspective here, show IP route OSPF, what you'll notice is I only have one route going upstream because it is a type 1 route. I'm only going to ask this for my CCNAs and CCNPs. Tell me in the comments OSPF's best pass selection criteria. And if you put that in there, I'll like your comment. So everything's going to end up going through router 6 and not 7 for a specific reason. Like I said, show me OSPF best pass selection. Put it in the comments. I'll like your comment. So we're good there. Now, here's the peer link here. I always use my peer links as PO999. So when you do this, it turns on bridge assurance. So, and you can tell because it does this spanning tree port type network. That basically saying bridge assurance is turned on, and it needs to be turned on the other side. So we're good there. So now from a VPC perspective, let's look at the VPC commands. So show run VPC. So here's the VPC commands, and let's go through these. So peer switch. This is going to make MLAG work from an L2 perspective. So downstream, you don't want the VPC pairs that have different IDs, right, from an L2, because then you can run into L2 issues. What peer switch does is basically say, hey, I'm going to look like one switch to my switches downstream. If you don't have that on there, you're going to run into a problem. Role priority, obviously, it's who's going to be the primary in the VPC. One is always going to. Cisco likes to play around with, okay, we're going to either make the shortest or the lowest number the highest priority, or the highest number the priority. So this one is the lowest number. Now the peer keep alive, I'm using the management interface. Some people don't want to use that. Some people use it, some people don't. Some people don't want to waste the link, especially when you have those 40 to 100 gig ports and you don't want to really waste a 40 gig port or a 100 gig port for a VPC keep alive. Some people use the management interface. So that command is peer keep alive destination, the IP address of the management interface. I'm sourcing it from my management interface. Now, the one thing you'll see here is I did type a command that says VPC management, but management is assumed by default. That's why you don't see VPC management. If you create a VRF called, like, if I would did this outside of management, I would say I would have a VRF that says like VPC KA for VPC Keep Alive, and then I would have my interface in there, and then you would see VRF VPC KA saying, hey, to get to my peer from a Keep Alive perspective, use this VRF. Peer gateway is a layer 3 command. Basically, if my secondary, it allows my secondary to answer for like a VIP. Like if traffic goes over to the secondary peer, I can answer it and route it, no problem. Again, from a VPC perspective, from a layer 2 standpoint, you don't have to worry about that. From a layer 3 though, it's separate routing tables. They do not share the same routing table. You can get burned on that if you think, hey, I share the same routing table as my other peer. No, they're independent routing tables. From a layer 2 though, they're the same. Now that command I told you was the layer 3 peer router, that allowed me to form an adjacency with the secondary peer if those packets go over the VPC peer link, which they do, which in this situation it did. Now you could potentially take off the VLAN or prune the PLAN from the VPC peer link, but you'll run into problems with the VPC from a layer 2 consistency standpoint. So give or take, you can't be messing around with that. Fast convergence is speeding up the convergence. Now, there's a way I could have put delay on here, but I didn't want to put too many commands. And then the last one is ARP synchronization because you want to make sure the ARP table is synchronized between the pairs. Basic VPC configuration stuff. And obviously, from a port channel standpoint, every time you create a virtual port channel on each peer, what you're going to do is you're going to add an interface to a port channel. So I believe if we do show port channel summary here, so you see my port channel 3 is a single interface, and it's in port channel 3, and then under the port channel, you have to give it a VPC ID. And that's going to sync between both pairs, and then the port channel will come up. Downstream, if this was like a non-nexus switch, it was like just a catalyst switch, you would just do a single port channel downstream on the downstream switch, and the port channel will come up. And this is what gives you MLAG, which is basically multi-channel link aggregation group, meaning the port channel from the switch downstream switch perspective, it looks like it's going to one switch, but technically it's going to two. Okay. So if you get an MLAG question in the exam or somebody asks you in the interview, what is MLAG? That is basically what it is. It's a port channel spread across, two switches. So we got all that. So I didn't show you the HSRP stuff because I did say I was doing that. So let's go to show run VLAN. Show run VLAN. I think it was 8. No. So let's see here. Which one is it? Oh, show run interface VLAN 8. What am I doing? All right. So here is the HSRP. Now there's no standby command like in Catalyst. Once again, Cisco, we need to stop with this trying to be smart and just have one OS, same commands on all platforms. We don't need to keep changing it. But on the Nexus platform, it's HSRP. Catalyst is still standby, right? So as you can see, we have our interfaces. We have some priority here to make sure that this switch becomes the priority in OS or the DR in OSPF, and the secondary is the BDR. Then we actually added to OSPF using this command. Again, looks different looks different in iOS XR, looks different in iOS XE. Then we have our VPC version 2. So this is going to change the multicast address. Now, if you know what the multicast address is for HSRP, put it in the comments. I like the comments because there's one for HSRP HSRP version 1 and HSRP version 2. So they are different multicast address. And then I use the HSRP 8. Now, if you were doing this in Catalyst OS, this would be standby the number, but this time they just do HSRP, and then we have our HSRP configurations here, especially with the VIP. So that's where the DMARC is, up here. Now, downstream, we have some 5Ks. This is just the next K. I just changed the icon to 5Ks. And it's the same configuration. The only difference is there's no L3 here. This is all L2. So the only thing we got here is the VLANs. So the only thing we got here are the VLANs, right? We got 8 through 10. And if we look at the features, section features, the only thing we got here is VPC and LSCP because it's all L2. On the switch above, we have OSPF. Yeah, I think OSPF. I have these LACP, VPC commands, and I think that is the only thing else that I have there. And if we look at from a spanning tree perspective, so we do span in VLAN 8, you will see that the root bridge is the one up top, and here's our bridge ID here. You see my root port is port channel 1, and then everything else is designated switches downstream, right? So our port channel 1 is on both switches, and it's the root bridge. So if I pull up the second switch and do the same commands, so span in VLAN 8, you will see port channel 1 designated, and we're good to go. Obviously, we got another root port here because that's the VPC peer link. What else do we got here from a secondary standpoint? Oh yeah, I need to show you the actual show port channel summary here. And as you can see, port channel 1 is ports 3 and 4. So 3 and 4 on 1, 3 and 4 on 5K2. Doing the VPC here. Show VPC brief. And as you can see, all my port channels are up. I think 4 is down because I just created it and forgot to delete it. So I need to just delete that so that doesn't have the consistency check. All right. So we got that there. And then in the data center world, if you're dealing with UCS servers, you know you have fabric extenders. This is just a normal IOL switch. There's no actual intelligence here, but for those that want to know what a fabric extender is, that is the intelligence of the UCS blade. So you are blade server, so you'll get the server, and then it usually comes with fabric extenders. And then if you're doing something like fabric channel over Ethernet or some kind of converged network, the fabric extenders will go into the LAN side of the network, and it will hook into the storage side of the network, which is over here somewhere, which is the storage side over here. I didn't configure any of this, so I just wanted to show you. But then it would go into the UCS blades or blade servers, and then that's how it talks to storage and gets out to the internet. So from a UCS perspective, these are going to just be normal trunk ports. And again, this is just normal IOL in the background, but I wanted to do this to simulate what it would look like. So from I believe, let's do show IP interface brief. So I'm 8.1. So I should technically, if everything is set up correctly from an L2, L3 perspective, I should be able to ping the VIP, and then I should be able to ping to the internet. So let's try this. So let's go ping to 168, 8.254, because that's the VIP. We got connection there. So the next one should be ping 1.1.1.1. And we are from my lab all the way out to Google. Or I think this is Cloudflare. Yeah, this is going to Cloudflare. So basically what this did is this went up to maybe, let's look from a spanning tree perspective, since I'm doing spanning tree on this. Okay, so this went this way. It went to fabric extender A in the diagram. So this went from fabric extender A to Nexus 5K1 all the way up to Nexus 9K1, and then to router 6, and then out to the ISP and to the internet. Now, if I trace route this, that's my guess. But if I trace route 1.1.1.1, can I source it? Or did I not spell trace route right? Yeah, I messed the R up. So if I go trace route, I mean, I don't need to source this. But let's see where it goes. So we got the L2. So my first hop should probably be, I think this is 253. Nexus 9K1. Oh, actually it's 252. So then it should go up here to 6. Yep. Then it should go out to ISP1. Yep. And then obviously going out to the internet. So that's all I really needed to see there. Yeah, I don't need to see anything else. Once it gets past this, I know that's ISP1. So the first hop was 8.852. So let's look on here and see if 52 is here, because that also, oh, okay. So remember I told you about that peer gateway command. This is exactly what I meant. So technically, it didn't go to 9K1. It went to 9K2. But because it can answer it, and this is the benefit of using that peer gateway command, I'm glad this happened because it actually explained it a lot better. So we go to show run interface VLAN 8. That's 2. And because we have the peer gateway, it answered the request and forwarded to the internet for me. If I didn't have that on there, it would have probably went over the VPC peer link and then went to 1 and then went out to the internet. And like I said before, independent routing table, so it already knew where to go. So it wouldn't make any sense to, hey, let me forward this to 1 and have that forwarded if I already know how to get there. And that's the benefit is when you do VPC, on Nexus platform, and you're on the L2, L3 demarc, right? When you're at the core, because some people make the VPC the core. So, or in most situations, VPC is going to be the core. But now you can see, hey, my second switch can answer for me and send me out to the internet, no problem. So this is back-to-back VPC in a nutshell. Like I said before, the concept is very simple. It's just we're going to have two different VPCs and two different VPC domains, and then you're going to do your VPC on both sides, and then you're going to port channel in between them. Like I said before, you may not see this in most environments. Nowadays, you're probably going to see a collapsed core design with VPC. Even when you have UCS servers, you'll just have the fabric extender, one VPC as the collapsed core, and that's it. So you may not see back-to-back VPC in the wild as much. It's still out there though, but not as much now with the invention of, BGP, EVPN, and all that good stuff. You may not see that anymore. Either you're going to see that or you're just going to see a collapsed core VPC design. Again, if you like stuff like this, because this is my bread and butter. This is the engineering side of me kind of lit up when I was like, oh, I get to do some more. Well, I mean, I like the security stuff, but I got to do, the CLI is where I like to live. But again, if you like stuff like this, please don't forget to share, comment, like, and subscribe. Share this one to, my CCNAs, CCNPs. Share this one to them so they can see where they can be if they just keep their head down, keep banging at the books, keep labbing every day. I keep telling you guys, lab every day because you will never stop learning. If you do that, subscribe to my channel. Hope you like this video. Thank you and have a nice day.